Hi everyone, I'm Bonnie and welcome to the masterclass for the lesson 5. We are going to first review some of the topics that was shown on the content, and then we are going to have a section about questions and answers. So if you have some questions, leave it on the comments and I will do all my best effort to solve your doubts. So first, I'm going to talk about it and then I'm going to do a little bit of live coding with you, and then we will have the question and answer. So I'm going to share my screen with you. Okay, the things that we review on the lesson 5 was communication with the sockets and the server and client model, and the serialization with XML, JSON, and DOM. Okay, about the communication, we have low-level APIs and high-level APIs. On the low-level APIs, we communicate between computers or with a mobile, with addresses, sockets, and interfaces. With the high-level APIs, we use URIs, URLs, and connections. Okay, with the sockets, with the low-level APIs, we are going to use the Java Sockets APIs, where we connect the server and a client. A server is like a computer or another device that is listening constantly to other devices. These devices could be a computer, a mobile, another server, and is constantly listening in one port. For example, 555 or 8080. This server is listening to one or multiple clients. The clients are another computer or mobile that can connect to the server. The server is listening all the clients, and each time a new client connects, it creates a socket. The socket is the interface between these two machines. Well, not the interface. The socket establishes a communication link between machines over the network. So we don't need to focus on other things on the internet, only the communication between the server and the client. And if we want a second client, we create another socket in the same port that the server is listening. So there is some types of socket. On Java, we can use TCP and UDP. First, the TCP has some properties. For example, reliability. That is because TCP is a connection-oriented protocol. When a file or message send it will get delivered unless connections fails. If connection lost, the server will request the lost part. There is no corruption while transferring a message. So the TCP ensures to send all the message. With the UDP type socket, is not is connectionless protocol. When you send a data or message, you don't know if it will get there. It could get lost on the way. There may be corruption while transferring a message. The order on TCP, if you send two messages along a connection, one after the other, you know the first message will get the first. You don't have to worry about the data arriving in the wrong order. On UDP, if you send two messages out, you don't know what order they'll arrive in. No ordered. So maybe you send five messages, and maybe the third will come first, and then the first one. That could be that could be because UDP doesn't matter the order. TCP does it. And because the TCP do a lot of things to ensure that the message is delivered is the is a little bit more heavy. Is heavy weighted because when the low level parts of the TCP stream arrive in the wrong order, resend requests have to be sent, and all the out of sequence part have to be put back together. So it requires a bit of work to piece together. For example, the TCP first receive the second packet and then the first packet. TCP will do the reorder. And for example, that we want to send a third message, but that message doesn't come, then the TCP will ask sometime later, and the message will be sent again. With the UDP, it's really lightweighted because it's not ordering the messages, it's not tracking the connection, and maybe if you send some message, will be lost. But it's really much quicker than the TCP and lightweighted. The TCP sends data with like a streaming. Data is read as a stream with nothing distinguished where one packet ends and another begins. There may be multiple packets per read call. But with the UDP, the data that uses datagrams, that is why it's named datagram socket. The packets are sent individually and are guaranteed to be whole if they arrive. One packet per one read call. So in the UDP, on Java, we use the datagram socket. And this is for the client and the server. And there is another subtype of datagram socket that is used on Java that is named multicast socket. This is used to talk with multiple clients in the same network. I'm going to do an example with code with you, but only with that TCP socket. So let me show you. Okay, we are going to do it by steps. So first, we are going to create the server. Oh, well, first let me show you how will this how this will work. So let me show you. Let me view if here is Java. Java version. Here is not. Let me open the command prompt. Oh, this is not working right now. Well, we are going to review the code first. The Java is okay. Oh, that's why Java is just version. My error, sorry. Okay. So I'm going to show you. First, I'm going to run the server. I already have it. Let me see. Oh, let me create it. Compile it. Oh yeah, that is because I have it on comments. And the client. Okay. I'm going to compile it. and the client. Okay, I want to create two windows. So let me open another terminal. It's better if you try it on Linux. I will then leave it in a, I don't know, maybe. Okay, on the desktop, I have it. Okay, ready? First, I'm going to run the server because the server is the one that is listening the other clients. And here I'm going to call the client. If you see, the server right now is listening, waiting for a client to connect. So here is the client. If you see, the client is connected. The application that I'm going to show you is named Echo. So when the client writes something, the server will receive it, and we are going to uppercase the message. And if I write that's it, this will send to the server that the connection is finished, and both programs will stop. Okay, now that you see it, we are going to code it. Okay, first with the server. We use with the server, as I said after, we used a server socket. The server socket we used, we assigned to the server socket which port we are going to listening. For example, right now, 8081. If you want another port, for example, 3000, you can do it. Only go and review which ports are available. And for example, I want to show you the API like here, the IP here. So I'm going to get it. This will be the IP client that I can get it with init address with get localhost. This will get the IP on the localhost. If you want to see your IP, you just have to do IP config on Windows, or in Linux, you will have to do if config. Okay, so if you see it, this is my IP on the public network, and on my local host, I'm using, let me show you. Oh, it's not showing it here, but normally is 170, 127.0.1. Most of the cases. Some other cases would be 0.1.0. Okay. So this instruction is getting my IP. Okay, then here with this instruction, the server will wait until a server is connected. If you see, I can run, let me show you the server. I can run the server, and here I created a new socket that I will be listening. And here I'm going to listen for clients. If a client, this will be stopping here, like stocked, until a client connect, because this server is accepting connections on the port 8081. So the first client that tries to connect, if I let me show you. The first client that connect will accept the connection, and the server will continue because a client is connected. So if you want to create multiple connections between multiple clients in the same port, you just need to call many times this instruction. But remember, if you want to attend at the same time multiple clients, you will need to do threading, multi-threading, as we saw on last lessons. Okay, let me kill this. Okay, continuing with the code. Remember, here we are getting the serve. We are accepting clients in with this instruction, and this is returning a socket object. As I said on the presentations, we create sockets to communicate between server and client. So here we are going to create the listeners and the writers. Okay, for the writers to communicate with the client, I'm going to use a print writer. So from the socket that I already created here, I'm going to get the output stream and I'm going to assign it to a print writer. So with this, I can write with to the client, and I'm going to create a listener. So from the client socket that I already create, I get the input stream and assign it to an input stream and the buffer reader. So here I'm going to read all the messages of the client. Remember, the TCP is talking with the communication between client server with the TCP is like a stream. So if you only do read, you will get a lot of messages until null. So if you want to segregate some of the messages, you can do some things like read line per line. So for example, I'm going to create a while, and here I'm going to show I'm going to read one line of the message, assign it on this variable, and I'm going to review if there is a null, because it's a stream connection, because it's like talking all the time. If there is no message, the client will send null. So we need to view if this is not null. If you want to see it, I'm going to print it just like this. And here I'm going just to print the message. You will see that there will be a lot of nulls. Okay. Let me compile the server again. Here is the client and here's the server. Let me show you this right like this. Okay, so here I'm going to compile the server again. Oh, sorry. Right there. And if I run it, this is listening to the client. Then I can connect the client. And if you see, there is connection. And I'm going to write anything. Okay. There was a little bit of error. Oh, this is because I'm doing it on Windows. Because on Linux, you will see a lot of null print line. And because I can't print a null, I can't show you. So that was like an error. Okay, let me return to the original code that I have it right here. Okay, so if you use Linux, you will see that we'll be printing a lot of nulls all the time until a message is received. For example, hello, and we'll show hello and again a lot of nulls, because we'll be waiting information from the client, like a stream. Okay, now here I'm going to get the client IP to show you, like the last time. Let me compile it again. Oh, come on. Right there. And execute it. I'm going to execute the client. Okay, so if I write something, okay. Here is the IP that the client is assigned to. If you see, it's the same IP because I'm connecting the client and the server in the same computer. And this computer is assigned to the same API on my network. If you try this in different computers that are connected in the same net, only sure to use here to add here the IP that you are going to use, like this one, or 192, something like that, dot 168. That will depend on your network, because that will be the public API, the public API, the public IP on the network that the computers are connected. So right now I'm showing the same only because I'm connecting on the same computer that has the same IP for the network. Okay, here I'm printing this, and here I'm printing what the client says. Then and I uppercase it right here, and then I print the message again. If you see here, uppercase it, and then send. If you see here, I am printing it, uppercase it, and here I'm going to write it to the client. So here I'm reading from the client, and here I'm writing to the client. So here is when the server sends the message to the client. See, that was the server was answering the same message but uppercase. So if I send a hello, this will uppercase it and send it. Oh, this is because it's Windows and was paused right there. If you use the terminal on Linux, this will be more quick. I really strong recommend only use Linux always. So here I'm just asking if the message was exit to finish the program. And here for example, if you see, I'm going to write exit, and that will be stopping. Okay, now here after what after I do this loop, asking reading the client, here I'm going to close the streaming to the output stream, and here I'm closing the input stream. Then I will close the socket that I already opened here. So here the socket is opened and here is closed. And that is all you need for a server. Now for the client, I'm going to show you step by step. Okay. First, this is the same. I'm going to get the IP to show you. And with this instruction, if you see, I'm not using server socket. I'm using a normal socket. So here I'm going for the socket, I need to specify the IP and the port to where I want to talk, because the server is just waiting for someone to connect and the client is trying to connect to the server. So here I'm going to create it. And in this moment, the socket will ask in this IP and this port if there is someone to talk, and the server will accept this connection, create a socket, and send to the client that is ready to have a conversation. This type of first conversation is named handshaking, because the client tries to say hi to the server. The server says, "Okay, I know that you are trying to talk to me. I'm ready." So he says, "Okay, let's start talking." And the client says, "Okay, I can start talking." That is like the handshaking. Okay, so here I'm just getting the IP. So, okay, here I'm going to create the stream. So this is the input stream. So here the client listens what the client wants to say. And here is the output stream. So the client can talk to the server. Okay, let me, oh, here I'm just talking with the input here, like as you saw that I was waiting user input. And then here, okay, here I'm writing to the socket to talk with the server. I'm sending here the message that I wrote on the user input, on the command prompt or the terminal if you are using Linux. Then let me, this is, let me see. Okay, here I will say this later. Okay, so here I'm getting the message from the server line per line, and I'm asking if there is a null. Remember that on Linux, this will be showing null, null, null if you print the message. And on Windows, maybe will be getting some error. So if you want to print it, ask first if there is a null. So here, I'm going to get the user input. Then let me, okay, here I'm writing to the server. And okay, there is okay. Here I'm asking if the message was on the terminal. If the message was exit, I will stop the program. And this is just to not ask again server data. Here I'm listening to the server, and here I'm writing to the server. When I stop this loop, I need to close the input stream, close the output stream, and close the socket. If you see, this is just a socket, and this is a server socket. Sorry, this is the server socket, and this is the object socket that is talking with the client. And in the client, this is the socket that is writing, that is talking with the server. So here I open it, and here I'm closing it. Okay, let me show you this again. I call the server, I run the client, so the client connect, I can write something, the server listen, and talk again to the client, see what the server is saying, and then I will stop the program. So here the server is closing all the connections, and the client too. See? Okay. This is better if you try it yourself. Here's all the code so you can try it. And let me continue with the presentation. Okay. We talk about the sockets and the communication, and I'm going to talk about the serialization. On the lesson 5, we talk about XML and JSON serialization. These are commonly used to communicate, for example, our Android application with a REST API. The REST APIs answer with documents that are uh, serialized with XML or JSON. Actually, right now is more used JSON than XML, but that will depend on the API that you want to talk. But it's really useful with the REST APIs. So with the XML, it's an extensible markup language. So you have a set of rules that you have to do to write an XML file. And this uses markups and content. So here, the XML syntax uses tags. For example, here is a tag quiz that if you see these symbols like less, like less than or greater than, here are the tag, and you need to close the same tag with this backslash. If you see, if you open quiz, you have to close quiz. And these tags are case sensitive. So if you need to write a Q with uppercase, you need to write it here too with uppercase because it's case sensitive. And well, there are elements. For example, this tag is an element, the element root, because it's the beginning of the document. This here XML version is just um, telling data about this document itself. Okay, here is the element quiz that has a child named Kanda. This element is child of quiz, and Kanda has two childs, question and answer. And this question has an element that is a text. And this answer element has a child that is text too. So, and if you want to write comments, you do it with this way. Okay. On the tags, you can specify attributes. There are some data that can help you to differentiate some elements. For example, here we have the section 1. So if I want to add another section, I can create a section with multiple questions and answers and name it sec2, section 2. Okay, so that was the tags, the elements, and the attributes. With the JSON serialization, the JSON serialization is derivative from the JavaScript object notation. So if you use JavaScript, it will be really similar to the JSON, and is more lightweighted than the XML. There is a lot of less characters that you will use to create a JSON document. JSON is a data interchange format. So with the JSON, you will have data that is stored like name and value pairs. So you say a name and then you will assign to that name a value. And multiple data are comma separated. On the values, you can specify strings, numbers, other objects, arrays, boolean, and null. So if you see, with the XML, mostly are like text always. With the JSON, you can specify multiple types of values, even objects or arrays. So here, I'm going to show you an example. Here, I'm opening the JSON file with these brackets, and these are braces and these are brackets. Okay, Here are the name that I said. Normally, if you see, this is a JavaScript object format. So for the JSON format, you only need to add here the same symbol, this symbol that is used with the strings. You will have to add it here on the name. Only that. Okay. So for example, there's the name hey and has a value with string that is set guy. Then if I want another element of data, here I have another name with a number value, then a comma, and here is another value that has another object. If you see, this object has braces too and can have other data inside it. So this object is a child of this one. And if you want, you can have arrays with different type of data. On Java, you can only have arrays that has the data on all the rows and columns, but on the JSON files, you can have multiple data with different types. For example, here I have 1, 2, and a string. You can have two booleans with true and false and null. There are some extensions that are doing, but this is more like the standard one. And remember to use here the string symbol. Okay. There is another type of document object that is a document object model that is named DOM. You maybe listen about it with the web things like the DOM or the virtual DOM or that kind of things. This will be really used on Android, and the DOM has a tree structure that has two types of nodes, the element node and the text node. And the DOM will have some functions to create nodes, remove nodes, change the content of the nodes, and traverse node between the hierarchy. So for example, I can have the document, a root element that can have two childs, for example, head and body. The head can have another child element that can name it title, and that title will have another child. You see element and text. So here's an element that has a child element that has another child element that has a child text. If you see, this is building a tree structure. Okay, so returning to the streaming. Okay, stop. Okay, so I'm going to look for your questions. Let me some seconds. Okay. Okay, there's no questions. So I will give you like 5 minutes if you want to write it here. So leave your questions. But if you don't have the time to ask right now, you can do it later on the forums. So I will give you some like 5 minutes. So I will show you a little bit of the code while waiting. So remember, here's the server and the client. If you use UDP, you use the same socket, the datagram socket for both client and server. Here, I'm just using TCP. So in the TCP, remember, the server creates a server socket that is listening multiple clients on the port that you specify. Then you can try to accept some connections with the clients. If you want multiple connections, you need to use a multi-threading. Then you can create and get the output stream to talk with the to write to the socket with the client, and you can get the input stream. Oh, sorry, I will share my screen. So here's okay. I'll be waiting for your questions. And I was talking about the code. Sorry, I was just reviewing it. And if you don't have questions right now, you can leave it there later on the forums. So I was saying that here you have the server socket, then accepting one connection to one client. If you want multiple connections to multiple clients, you need multi-threading. And here I'm getting the output stream, the input stream. Here I'm talking with the client. I'm reading, and here I'm writing to the client. Then you have to close both the input stream and the output stream, and then close this socket. With the client, you only need to try to connect with the server. So you specify the IP and the port that the server will use, that the server is listening. So here the client tried to connect to the server, then the server accepted here, and the client creates a socket object where I can get the input stream, the output stream to talk with the server in this socket. And here I'm listening line per line to the server. And here I'm writing to the server through the socket. Okay, so if you don't have questions, I will stop the streaming right here, right now. So if you have more questions, let me stop this. So if you have questions, leave it on the forums later and we'll be answering them. So thanks for listening, and we'll see you on the next masterclass. Bye everyone.